Hey guys, it's Nick.
And Ellie.
And today we're going to teach you guys about the reflection, refraction, and reverberation of sound waves. You guys hear that? That's an echo. Have you guys ever wondered why there's an echo when you bounce a ball in the gym? Well, today we're going to teach you about it.
Sounds are reflected by most, if not all, surfaces. More rigid and smooth surfaces reflect most of the sound that bounces off of them. More soft and irregular surfaces reflect a low amount of sound that bounces off of them. Have you ever wondered why you can scream into a pillow and nobody hears it that much? Well, that's exactly why. The soft material of a pillow results in a low amount of sound, so screaming into a pillow diminishes the total noise output. Also, when sound reflects off of a surface, the angle of incidence is equal to the angle of reflection, as depicted by this picture drawn by Nick. If a sound reflects off a surface, the results can be determined by our sense of hearing.
The reflection of multiple sounds off a surface is called reverberation. This may occur if the surface reflects more than normal. When a sound reverberates off of a surface, it often becomes unclear because of the many sounds coming from many different locations. There's a large difference between echoes and reverberations. In an echo, there's a short gap at the time between the initial and the reflected sound. It is a recognition of a reflected sound wave. In a reverberation, there is no time gap between the initial and the reflected sound, so that is why we perceive it as one long, unclear sound. And this can be shown in Ellie's beautiful drawing.
Refraction is the bending of a sound wave being transmitted through a medium. This bending is mostly a result of uneven temperatures. One way this is relevant is on a cold lake in the morning. Early in the morning, the lake is cold and therefore makes the air above it cold as well, while the rising sun heats the air above the cold air. The result of this is that the sound is amplified toward the lake because the warm air above the lake increases the speed of sound waves because there are more collisions and movement, while the cold air slows down the sound wave because of less collisions and movement, and this produces a bending of the wave toward the lake. So the fishermen getting their catch of the day early, the sound of their fellow fishermen yelling at them would be amplified. Hooking, right?
Haha. Going back to reflection, another example of how reflection is present in our world today is how you see a baby in the womb. An ultrasound! In short, the inside of the organs don't reflect the ultrasonic waves as well as the outside of the organs do. And this is how you get a silhouette of the organ. Okay, and we're here with my mother, Dr. Shil Sanders. Say hi, Mom.
Hi.
Hi. And so she's gonna explain to us what happens in one of these ultrasonic devices. So, Mother.
What we have here is a ultrasound machine. This is a 2D ultrasound, which gives you, of course, a two-dimensional picture based on ultrasonic sound waves. The machine will emit these ultrasonic sound waves. You use this, there's different types of probes which will also pick up varying frequencies. We have this one and we have this other probe, once again for different frequencies, using this ultrasound gel. It's a conduction medium which helps to transmit the sound waves from this machine in through this probe, and as it contacts various parts of the body, it will give you a picture based on the density of the various tissues.
Okay, so my mother is currently reading or seeing my heart, and here it is on the screen. Pretty neat. Guys, thanks for watching.
Thank you.
Learn a lot.